You are standing in a world where the sky still feels untouchable. The stars are fixed. The moon looks smooth. Jupiter is just a bright dot. Then, someone hands you a tube with glass at both ends, and suddenly, the universe starts making embarrassing mistakes. The moon is bruised. Jupiter has company. Venus has phases. The heavens are not perfect, and that is a problem if your whole civilization is built on the idea that they are. That tube is small. It looks almost harmless, but it changes everything. Before the telescope, astronomy was mostly patience. People watched the sky, tracked patterns, and told stories about what they saw. The sun rose here. The moon moved there. Certain stars came back each year like clockwork. You could measure the sky. You could admire it. But you could not really test it. The universe stayed far away, like a painting hung too high on a wall. Then Galileo lifted a telescope and pointed it at the moon. You expect beauty. You expect a smooth silver ball. Instead, you see damage. The surface is rough. Dark craters bite into it. Mountains cast long shadows across the light. The moon does not look divine anymore. It looks physical. It looks like somewhere you could trip and fall. Then, Galileo turns the same telescope toward Jupiter. At first, it is just a bright planet with a few tiny dots beside it, but he keeps watching. The dots move. One disappears. Another reappears. Night after night, they shift position, like tiny dancers circling a fire. Those dots are moons. That one sight cracks open the old universe. If moons can orbit Jupiter, then not everything revolves around Earth. The sky is not arranged around us like a stage set. It has its own structure, its own traffic, its own rules. The telescope did not just magnify the heavens, it exposed them. But early telescopes had a problem. Their lenses bent light, and light did not like being bent that way. Bright objects grew colored halos, details blurred. The more you pushed the instrument, the more the instrument pushed back. It was like trying to read the universe through bad glass. That led to an uncomfortable thought. Maybe the sky was not the thing failing us. Maybe our tool was. Isaac Newton attacked that problem with a different idea. Instead of using lenses to bend light, he used mirrors to bounce it. A curved mirror gathered light at the back of the telescope. A smaller mirror redirected that light into the eyepiece. The design was simpler in one important way. It stopped the color mess that lenses kept creating. That sounds technical. It was not just technical. It was a door opening. Once mirrors took over, telescopes could grow much larger. And when a telescope gets larger, it collects more light. When it collects more light, the faint things begin to show up. You point one of these better telescopes into the night, and the sky starts filling with ghosts. Soft clouds, faint swirls, weak smudges so dim they almost feel imagined. For a while, no one is sure what they are. Maybe gas, maybe nearby clouds, maybe little scraps of the Milky Way. Then the truth lands. Some of those smudges are not inside our galaxy at all. They are galaxies, whole star cities floating impossibly far away, each one carrying billions of suns. The quiet night sky above your head is no longer a ceiling with lights pinned to it. It is depth. It is distance. It is a dark ocean filled with islands you cannot reach. The universe was not blurry, but even perfect mirrors could not beat Earth itself. The atmosphere above us looks invisible and calm, but it is always moving. Hot air rises, cold air sinks. Wind twists through layers you cannot see. Every bit of starlight has to swim through that moving mess before it reaches the ground. That is why stars twinkle. People love that word. Twinkle sounds magical. For astronomers, it means something far less romantic. It means Earth is smearing the universe in real time. The planet under your feet is acting like a dirty lens. So eventually humans asked the obvious question. What if we just got out of the way? That is how Hubble happens. In 1990, the Hubble Space Telescope goes up, above the atmosphere, no air, no shimmer, no blur from the sky itself. For the first time, a major telescope gets a clean stare at the universe. The images come back, and they are almost rude in how much they reveal. Galaxies are no longer fuzzy blobs. They have structure, spiral arms, bright cores, dust lanes. Nebulae stop looking like pale stains and start looking like giant nurseries where stars are being born. Then Hubble does something even stranger. Astronomers point it at a patch of sky that looks empty. Not dramatic, not famous, just black. A tiny square of nothing. You would expect a few stars, maybe. Maybe not even that. Hubble stares at that darkness for days. When the image comes back, the black is gone. In its place are thousands of galaxies. Not stars, galaxies. Huge systems full of stars, packed into a slice of sky so small it would fit on the tip of a finger held at arm's length. The part of the sky that looked empty was crowded beyond belief. Space was not empty. Our view was. But light has more than one language. Visible light is just the one human eyes happened to evolve around. The universe does not care about human eyes. It also sends out radio waves, X-rays, gamma rays, and infrared light. If you only look in visible light, you are not seeing the whole show. You are catching one instrument in an orchestra. That brings us to radio telescopes. A radio telescope does not look like the classic idea of a telescope at all. No long pirate tube, no little eyepiece pressed against your face. Instead, you get giant dishes built to catch whispers. The signals they collect are weak, stretched out, and often ancient. A radio dish has to be enormous because the universe is not shouting in this band. It is murmuring. Fast is one of the best examples. It is so large, it sits inside a valley, more than 500 meters wide. Less like a machine and more like a wound in the landscape. You are no longer building a tool that fits on a mount. You are shaping geography into an ear. And once we started listening, the universe changed again. We found pulsars, crushed dead stars spinning so fast they sweep beams through space like lighthouse lamps. We mapped hydrogen drifting between stars, the raw fuel of future suns. We stopped just looking at the galaxy and started overhearing it. Then, radio astronomy went one step further. What if one dish is not enough? What if you connect observatories across the whole Earth and make them act like one giant eye? That is the Event Horizon Telescope. Not a single building, not a single dish. A network spread across the planet, all working together. A telescope as wide as Earth. And in 2019, that planet-sized eye gave us something people once thought might be impossible. The first image of a black hole. Not the black hole itself, because no light escapes that, but the glowing ring of superheated gas around a dark center where gravity wins completely. For the first time, one of the strangest objects in physics stopped being only math and became something we could point at. The universe was not silent. We just did not know how to hear it. Then came Webb. If Hubble gave us a clean view, Webb gives us a deeper one. Many of the most important places in the universe are hidden behind dust, star nurseries, young galaxies, regions where visible light gets blocked, like headlights in fog. Webb is built to see infrared light, which can slip through that dust far better. Its design already tells you this is a different beast. 18 gold-coated mirror segments. A giant sunshield stretched behind it like a silver kite. Everything about Webb is built around one mission: stay cold enough to detect faint heat from the deep universe. That is the trick. Webb is not just seeing light, it is catching warmth. The faint infrared glow of things so distant that their light has been traveling for more than 13 billion years. You aim Webb into deep space, and it does something that sounds fake, until you remember physics allows it. It looks back in time. Not metaphorically, literally. The farther away something is, the longer its light has taken to reach us. So, when Webb sees ancient galaxies, it is seeing them as they were when the universe was young. Distance stops being just distance. Distance becomes time. Webb does not simply show us remote objects. It shows us early chapters of reality, galaxies still forming, light still climbing out of the first great ages of the cosmos. And just when that feels like the peak, the telescope story changes again. For hundreds of years, telescopes mostly did one job better and better. They took improved views, bigger, sharper, deeper. But the sky itself was still treated like something mostly still, a place you visit, photograph, and move on from. Rubin changes that. The Vera Rubin Observatory is not built to take one perfect portrait and stop. It is built to scan huge stretches of the sky, over and over, night after night, building a time-lapse of the universe in motion. It will watch for things that move, flare, explode, dim, appear, and vanish. Asteroids sliding through the dark. Stars blowing themselves apart. Galaxies suddenly brightening. Objects that were not there yesterday. It will send out millions of alerts. Not over years, over nights. That is not just better astronomy. That is a different kind of astronomy. The sky stops being a museum. It becomes a live feed. That may be the biggest shift of all. Galileo showed us that the heavens were not perfect. Newton showed us our tools were the bottleneck. Hubble showed us Earth was blurring the truth. Radio telescopes showed us the universe was broadcasting. Webb showed us the past is still visible. And Rubin is about to show us that the sky is not sitting still for our convenience. It is happening. That is the real story of telescopes. Not just better machines, better ways of being wrong. Every time humans build a sharper eye, the universe punishes our confidence and rewards our curiosity. The moon stops being smooth. Jupiter stops being alone. Empty darkness turns into thousands of galaxies. Silence turns into signals. Distance turns into time. The calm sky turns into a storm of live events. 400 years ago, the universe looked neat, quiet, and untouchable. Now we know it is crowded, violent, old, and constantly changing. And if this story has a pattern, it is a dangerous one. Every time we build a better telescope, the universe gets weirder, which means the sky you think you understand right now is probably still hiding another embarrassing mistake.